Okay, welcome back. We're going to take a look at this lesson, which is basically covering two more features with distributed switches that for the cases where customers need these features, they're there. Maybe not everybody's going to use all these features all the time, but just like in a physical network, when you need these capabilities, it's available in your virtual network as well. NetFlow is an important feature that we have available. We've had that since vSphere 5 days, and also port mirroring. We've had that since the vSphere 4 days. So it's been in the product for some time. And NetFlow was actually introduced in 5.0, but it was updated up in vSphere 5.5, and it's still leveraged, of course, today. So let's take a look, right? We're going to describe how to use NetFlow for monitoring your network security and analysis, and also configure port mirroring on your distributed switch. So NetFlow, right? It's an industry standard service, right? That you typically would put on your physical network to analyze networking, profiling, intrusion detection and prevention, forensics, for instance, compliance monitoring. But, with a physical network, what you're doing is you're looking at the traffic that is traversing from one switch port to another switch port. If those were two PCs, for instance, well, then we'd be able to monitor the networking statistics between those two different machines as they connected to the same physical switch. But when you have two virtual machines that are on the same ESX server and they're on the same virtual switch, there's a possibility that those two VMs can talk to each other over the virtual network, but that never hits the physical network. That's going to be hard to manage, hard to see, hard to capture. Same thing when you have, say, for instance, a VM on one host and a VM on another host. Well, okay, those two VMs are going to be able to communicate with each other, but they're going to hit the physical network like they should. But from the physical network's perspective, that's going to look like two ESX servers that are talking, not necessarily two VMs on each of the different ESX servers that are actually doing the communicating. So we would see these as a kind of an example of when you have two VMs on the same host, that would appear to be an internal flow, essentially, right? They're internal to the ESX server and never hit the physical network. And then when you have two VMs that are on different ESX servers that are communicating with each other, they'll be using the physical network. Well, we would call that an external flow. So if we want to capture that in the NetFlow collector, however you set that up, it's not a virtual infrastructure necessarily. Sure, you can have virtual NetFlow collectors, but that's not necessarily what we're talking about. We're just saying that there's a NetFlow collector in your network somewhere that needs to capture the networking statistics. Now, the NetFlow collector is not gathering payloads or anything like that, but it's gathering the amount of bandwidth and the throughput between the different VMs or between different physical servers. What we want to be able to do here is have that NetFlow collector capture the traffic where maybe the traffic isn't hitting the network at all. That example of an internal flow between two VMs on the same ESX server on the same virtual switch, or capture traffic that would be recorded as an external flow between VMs across ESX servers, or maybe even from a VM to another physical server, it will cross the physical network in that case as well. So we need to be able to record these. These are all called flow records. And those flow records that include whether or not the traffic was an internal flow or an external flow on off to the NetFlow collector. So normally by default, the distributed switch doesn't do all this. We would need to configure the distributed switch to perform these functions. What you do as a top level consideration is you'll need to tell the distributed switch who the NetFlow collector is by providing its IP address. Another thing you're going to do optionally though is give the distributed switch its own IP address, right? You have to tell the distributed switch who the NetFlow collector is. That's a mandatory step. But what is optional and is in fact recommended is to grant the distributed switch its own IP address. Now, this is not to make that distributed switch some kind of managed object in your network, and it's not even an address that needs to be communicated with. All this is doing is providing the distributed switch with an identity on the network. This address that you give the distributed switch doesn't even need to be pingable. It just needs an IP address. Probably talk to the networking team, find an IP network or an IP address that isn't used, and just give that to the distributed switch. And then you'd record that in your NetFlow collector that IP address is the IP address that belongs to your distributed switch. If you don't do this, what ends up happening, remember, all the networking I/O in a distributed switch is coming in and out of the ESX servers. So the ESX servers ultimately are the systems that are sending the NetFlow data to your NetFlow collector. And since if you don't include an IP address for the distributed switch, what will happen is the ESX servers will use their own IP addresses as the source NetFlow address. So what would happen is your NetFlow collector would be gathering all these NetFlow records from a variety of different ESX servers, all with their own IP addresses, making it a little bit more challenging to track it all. It is far simpler to have the NetFlow collector gather information from a single source, the IP address of the distributed switch. So it's not mandatory, but it's recommended to give that distributed switch an IP address. But again, it doesn't need to be on any actual connected or routable network. It doesn't need to even be a pingable address. It's just being used as an identity for our NetFlow collector purposes. So remember, the NetFlow collector, right? It's going to store the flow-based data, analyze this information, right? This is going to include all of this information, statistics about the gathered information from NetFlow. So for instance, it's going to contain, the NetFlow collector, a storage system that's going to have long-term storage for all the flow-based connections to let you isolate network bandwidth use, investigate, and troubleshoot for all kinds of different types of potential network issues out there. Right? You can look at the historical records to diagnose the cause of outages or breaches, for instance. And so it mines, it aggregates, and it reports on all this collected data, letting you analyze or have the ability to analyze network traffic by rate, volume utilization, and also trends in VM and host traffic. But again, it's not there to capture the payloads necessarily. It's there to gather the statistics about the networking traffic, which would include or could include your virtual traffic. That's really what we're going for here, right? The whole point of this is that you might already have NetFlow recording your physical networking I/O, but let's also, if you need to, capture the information from your virtual network as well. So to do this, you go to the distributed switch first, right? So here we are in DVS Lab. We go into its configure settings, find the NetFlow settings, and basically enable it, right? You do that by first setting up who the collector's IP address is, adding the distributed switch's IP address, and then make sure that it is enabled, and then you click OK. That's all you really need to do. Set up some default settings, but ensure that the service is enabled. But now that actually isn't the whole story here. You still need to choose which port groups on that distributed switch will have their data collected by the NetFlow collector. So this is nice. You don't have to do a coarse grain, all or nothing kind of situation. You can have one distributed switch with all these different kinds of traffic types and all these different port groups, and then pick and choose which port groups are going to send their NetFlow data over to your NetFlow collector. So here we are setting it up on our VM traffic SA production. That makes sense. We're monitoring the traffic between virtual machines. And so we go ahead and enable it for my VM traffic. But, for other types of traffic, like for instance, iSCSI or maybe vMotion, I wouldn't think those are going to be things that you necessarily need NetFlow data. You might need to, but that's where you can pick and choose which of the different port groups are going to have their data collected by the NetFlow collector. So that was a look at NetFlow. Stay tuned next. We're going to come back from a quick break and take a look at port mirroring. So see you in a few minutes.